Hello everyone, welcome to EC8553 Discrete Time Signal Processing lecture video. This is Manimeglayal, Assistant Professor ECE from R.M.K College of Engineering and Technology. In this video, we are going to see about how to solve a DFT using DIT FFT, which means we are going to find the discrete Fourier transform of the given time domain signal x of n using the decimation in time fast Fourier transform algorithm. So here we have given a question. An 8-point sequence is given by x of n is equal to 2, 1, 2, 1, 1, 2, 1, 2. So the question asks us to compute 8-point DFT of the x of n by radix to DIT FFT. So from the given question, we can conclude that the sequence is of 8-point. And here they have specified the method to find the DFT using radix to DIT FFT. So our first step is we have to determine the n point, that is the number of points given in the input signal x of n. So it is an 8-point sequence. So our n is equal to 8. For radix to FFT, the number of stages is determined by 2 power m, that is r power m. The radix 2 is r represented here. M is the number of stage. So 2 cube is equal to 8. So that will be getting the number of stages is 3. So for solving an 8-point DIT, we require 3 stages. So then, since we are computing using DIT FFT algorithm, the given input signal is arranged in the bit reversed order. So we are going to see how it is arranged by the bit reversal. So now the normal order. So x of 0. So x of 0, the 0 here is in decimal. You can represent it in binary in form of 3 digits. That is x of 0, 0, 0. And x of 1, the 1 is in decimal. We can represent using the binary bits as 0, 0, 1. And the next thing is x of 2, that is represented using 0, 1, 0. And x of 3 is 0, 1, 1. And remaining 4, 5, 6, 7 vice versa are represented by their binary sequences. And bit reversed order, if you could see here, the MSB becomes LSB of our bit reversal sequence. So this first MSB 0 will become the LSB 0 here, and the next 0 will be following, and this LSB becomes MSB. So 0, 0, 0. And for x of 1, the transformed bit reversed binary bits are this LSB 1 becomes MSB here, followed by the next 0 and followed by the next 0. So it is 1, 0, 0, which is nothing but 4 in decimal form. And x of 2 is determined by 0, 1, 0. And if you reverse, we'll be getting the same sequence again. So x of 2 is x of 2. And x of 3, the bits are 0, 1, 1. And if you could reverse this, we'll be getting 1, 1, 0. The equivalent decimal number is 6. So x of 3 will be transformed into x of 6 using the bit reversal technique. And similar way, x of 4 becomes x of 1, and x of 5 becomes x of 5. X of 6 changes to x of 3, and x of 7 changes to x of 7. So this is the bit reversal order. So we have to feed the input to the algorithm in this order, which means x of 0, x of 4, x of 2, x of 6. So all the even numbers will come at the first half, and x of 1, x of 5, x of 3, x of 7. And the odd part will form the second part. So that is the sequence given in here. So normally x of 0, 1, 2, 3, 4 and 5, 6, 7 are written from the given sequence x of n. And the bit reversal sequence according to this order is given as the input. So my x of 0 value is 2 from the sequence, and x of 4 value is 1 from the sequence. Here also you can find, and from our table also you can find. So according to the bit reversal order, we have to write the given input sequence x of n. so that we can feed it to the algorithm. So now our algorithm. So this is the 8-point DIT FFT structure. So we can see the input feed here. X of 0 is the first, and X of 4, X of 2, X of 6, followed by X of 1, X of 5, X of 3, X of 7 as per the bit reversal order. So we have seen there are 3 stages of computation for this DIT. So stage 1 will be comprising of 4 2-point butterflies. So since our n is equal to 2, here if you can find the twiddle factor or the phase factor, W 8 by 4 part 0, which is W 2 part 0. 8 by 4 will fetch us 2, so W 2 part 0. So W 2 part 0 is the twiddle factor used for our first stage of computation. And in the second stage, we can see 2 4-point butterflies, and we need a twiddle factor for W n by 2 power 0 and W n by 2 power 1. So W n by 2 power 0 means W 8 by 2, which is 4 power 0, W 4 power 1. And similar way for the second 4-point butterfly. And third stage will comprising of one single 8-point butterfly. So for that we need to have 4 twiddle factors. So Wn0, Wn1, Wn2, Wn3. So Wn0 means W80 and W81, W82 and W83. So these are the stage 3 twiddle factors, and we can compute this DIT by this stages in separate manner. So for stage 1, first we can compute, and that output will be acting as the input to the stage 2. And similar way, if you compute for stage 2 and get the output, that output will be acting as the input for the stage 3. So this is called as inline computation in FFT. So for stage 1, the input is fed as the bit reversal order. So X of 0 is 2 and X of 4 is 1, X of 2 is 2, X of 6 is 1, X of 1 is 1, X of 5 is 2, X of 3 is 1, X of 7 is 2. This 2 is the first input that will be reaching in here. This 1 will be also reaching here. So 2 plus 1 will be getting the output as 3. And similar way, this 2 will reach here as the first input, and this 1 multiplied with minus 1 will be reaching here, which is 2 minus 1, that is equal to 1. The total factor of this stage is 1, so we can ignore that 1. And the second butterfly, this 2 is the first input that will be reaching here. This 1 will also reach here, so 2 plus 1, 3. And the second input is this 2 will be reaching here. This 1 multiplied with this minus 1 will reach here, so 2 minus 1 is equal to 1. Similar pattern, we can calculate the third 2-point butterfly and fourth 2-point butterfly. We can get the output. So this output is 3 1 3 1, 3 minus 1, 3 minus 1. So this is the first stage computation output. This sequence is going to be acting as the input for the second stage, stage number 2. So this is the stage 2 structure. So we need phase factors, that is a twiddle factor, W40 and W41. So W40, the value is 1, and W41 is cos of minus pi by 2 plus j sine minus pi by 2. So the value is minus j. So since cos minus pi by 2 is 0, sine minus pi by 2 will be taking the value minus 1. So minus 1 multiplied with j will be getting minus j. So now here we can give the twiddle factor. So for the third line, the twiddle factor is placed, which is 1 W40, and for the fourth line, W41 is twiddle factor, that is minus j. And for the second 4-point butterfly, in similar way, the third line the twiddle factor is 1, and for the fourth line it is W41 minus j. So this 3 will reach here, and this 3 multiplied with twiddle factor 1 will be reaching here. So 3 plus 3 is equal to 6. And for the second line, this 1 will be reaching here. This input 1 will reach here. The next input is 1. So this 1 multiplied with minus j will be reaching here. So 1 plus 1 into minus j, which is 1 minus j. This is the effective output of this stage. And here this 3 multiplied with 1 will be reaching here, that is 3, and 3 into total factor 1 into minus 1, minus 3 will be reaching here. So effective value is 3 minus 3, 0. And for the fourth line, the first input is this 1, that will be reaching here, and the second input is 1 into minus j, that is minus j, will be reaching here. The answer is 1 plus j. So this is the output for the first 4-point butterfly of stage 2. The second 4-point butterfly output is this 3 will be reaching here, and this 3 multiplied with 1 will be reaching here. So 3 plus 3 is equal to 6. And here this minus 1 will reach here, and this minus 1 multiplied with minus j will reach here. So that will be getting minus 1 into minus j plus j. So minus 1 plus j, it is the effective value here. And at this third line, the first input is from here, this 3 will reach, this 3 will reach here, and this 3 multiplied with 1 into minus 1. So 3 minus 3 is equal to 0. And the fourth line, this minus 1 will reach here, and this minus 1 into minus j, this minus 1 into minus j into minus 1 will reach here. So that will be getting minus 1 into minus j, that is plus j, and already we have a minus here, so this is minus 1 minus j. So these are the output of stage 2. So writing the output of stage 2, that is 6 comma 1 comma minus 1 minus j comma 0 comma 1 plus j comma 6 comma minus 1 plus j comma 0 comma minus 1 minus j. So this second stage computation output is going to act as the input for the third stage. So this is the phase factors or total factors required for the stage 3 computation, which is W80, the value is 1, and W81, the value is 1 by root 2 minus j 1 by root 2, and W82, the value is minus j, and W83, the value is minus 1 by root 2 minus j 1 by root 2. This is the stage 3. Here we'll be having one single 8-point butterfly. So the previous stage output, that is 6, 1 minus j, 0, 1 plus j, 6, minus 1 plus j, 0, minus 1 minus j, will be acting as the input for this stage, and total factor are fixed for the lines accordingly. So 1 is W80, and 1 by root 2 minus j 1 by root 2 is W81, and W82 is equal to minus j, and W83 is equal to minus 1 by root 2 minus j 1 by root 2. So this 6, the first input is this 6, that will be reaching here. So we'll be getting 6 plus this 6, so that is 12. And second input is here for second line, this 1 minus j plus the second input is from here, minus 1 plus j multiplied with this total factor will be reaching here. So after multiplication and simplification with this 1 minus j, will be getting 1 plus j 0.414. And for the fourth line, this input 0 will reach here, and the next input is from here, 0 again. So 0 into minus j, that will reach here. So 0 plus 0, the effective value is 0. And for the fourth line, 1 plus j will reach here, and this second value is minus 1 minus j multiply with the total factor, that is W83, which is minus 1 by root 2 minus j 1 by root 2, that will be reaching here. So after simplification, the value is 1 plus j 2.414. And the fifth line, the first input is 6, that will reach here, and this 6 into this minus 1 will be reaching here. So 6 minus 6, the value is 0. Similarly, for the remaining 3 point, the value is calculated as per the algorithm as we have done with the above lines. So upon simplification, we'll be getting the output. So this is the output of the DIT FFT algorithm. So x of 0, here we can find upon feeding the input that is in bit reversal order, but the output is in natural order, which is starts from 0 and ends at 7. So x of 0 is the first input, that is 12, and x of 1 is 1 plus j 0.414, and x of 2 is 0 again, x of 3 is 1 plus j 2.414, x of 4 is 0, and x of 5 is 1 minus j 2.414, x of 6 is 0, and x of 7 is 1 minus j 0.414. So we can write this output stage as a sequence, and this is the DFT of our given x of n. We can write it as x of k, which is the DFT notation. So x of k is equal to 12 comma 1 plus j 0.414, 0 comma 1 plus j 2.414 comma 0, 1 minus j 2.414 comma 0, 1 minus j 0.414. So this is the output of the given x of n. This is how we have to calculate the DIT algorithm. So first we have to find the given endpoint, so which is in the power of 2. Here we have got 8-point sequence. So 2 power 3 will give me 8. So the number of stages is 3. So from the stages we can calculate the stages separately, and the final stage output is the DFT of the given x of n. So for DIT, the input is bit reversal sequence and the output is in normal order. So thank you.